So here is how the first one we're going to look at will kind of be worded. So I have region S is bounded by the graphs of y is equal to 6 minus 2x, y is equal to 0, and x is equal to 0 as well. First step, similar to area, you want to have some sort of idea what this region looks like. The y equals 0 and x equals 0 is just the x and y axis. Y equals 6 minus 2x, that is just a line with a slope of -2 and a y-intercept of 6. I'm just going to kind of draw my sketch of it. I know it's starting at 6. It is bounded between the x and y axis, so 0 is also kind of a point on it. I'm going to go ahead and also find where it's crossing the x-axis at. How do I find where it's crossing the x-axis? I can go ahead and just set the function equal to 0 and solve. Add 2, divide by it, and we get x is equal to 3. So just like with area, that is the region that we have. And how we're visualizing this, for those of you who do have kind of the spatial skills to do it, you're looking at a bird's eye view of this solid. So this solid is coming straight out of the page towards you. Like if you were to kind of go down and look at it along the side, you'll see the cross sections. But we have the region, and then you always want to pay attention to which way you're slicing it. That will tell you whether you're doing it in terms of dx or dy. So S is the base of a solid, and cross sections are perpendicular to the x-axis are semicircles. So there is the way we're slicing it. I like drawing in the slice just to visualize it. Since that slice is perpendicular to the x-axis, is this going to be a dx problem or a dy problem? A dx problem, because we are connecting top to the bottom. Where the semicircle comes into play, imagine if you're staring down a solid and you can reach straight into the page. If you were to pick up that purple one, you're looking at like the top of a slice of bread, and if you were to pick it up, it would look like a semicircle. So like closer to the y-axis, bigger semicircles, closer to the 3, smaller semicircles. And it's forming like, I'm no artist, but it's kind of like a tunnel that goes down to a point. So you have like the big semicircles down to the smaller ones. So let's go ahead and write an expression for it. It tells us that the base is in S. So 3-step process. First step, we want to write an expression for the base. Since this is a dx problem, are we going to be top minus the bottom or right minus the left? Top minus the bottom. The top function is that line. What's technically the bottom function? 0. Like the bottom function is technically 0. Could I have left off that -0? Sure, like it's just -0. Step 1. Step 2 is we want to write the area in terms of B. It tells us this is a semicircle. What's the area of a semicircle in terms of B? And look back if you need to. Pi over 8b squared. Again, if you don't remember that, then you get to like derive it each time. And then I'm going to go ahead and plug in what b is equal to. So I have pi over 8 b squared. And what was b? 6 minus 2x minus the 0. And again, I could leave off that minus 0. And then final answer. Volume is going to be the integral of the area of one slice. So I'm going to integrate the area. Don't leave off the dx. What numbers do we think are going to go in the integral sign? 0 to 3. So we're doing it in terms of x, so 0 to 3. I would leave my answer like that. It told me to set it up but not evaluate it. If you wanted to simplify it, so pi over 8 is a coefficient, so it can be brought on the outside of that integral. And then that base, 6 minus 2x minus 0, is just 6 minus 2x. Don't forget the squared or the dx. I would probably just leave it in the one that I have in orange. It told me not to evaluate it. Do realize if you did have to evaluate this one, you would have to FOIL that, then use the power rule, then do top minus the bottom. But we're just going to set it up because that's what it told us to do. Questions on that process? Shortcuts. We all love a shortcut. If you can do all of that without showing the 3 steps distinctly, that's perfectly fine as well. And that's how I tend to do it. So I'll like write down the base, then fill in like the area around it, and then fill in like the integral around that. Now that's how I'll do the next one. As long as you identify the 3 parts kind of correctly, you're going to be fine. So let's go ahead and look at the second example. Same region, so I'm going to just kind of redraw it real fast. We have that region S, we have the straight line, we still have the axes. It's going at the 6 in the y, 3 in the x's, and at 0. Looking at this question, for example, 1b, what's the only thing I changed about the problem? The y-axis, the way that I'm slicing it. So instead of slices going up and down, we're now perpendicular to the y-axis. So now my slices are going this direction. It is going to be a similar shape, but this is a completely different solid. Again, those slices I left the same. It's a semicircle. I could have changed that as well, but I left it at a semicircle. So let's go ahead and think about what we need to do. Is this going to be a dy or a dx problem? dy, if we're connecting left to right, it's dy. Since it is a dy, what do I need to do with my function? I need to put it in terms of y. I need to solve it for x. So I'm going to go ahead and solve it. So that's going to be add the 2x to both sides, subtract the y, and then divide by the 2. So now it's in terms of y. And I'm going to go ahead and do all 3 steps in the same line. I'll color code it so you can kind of see where it's coming from. Step 1, I need to write an expression for the base. Am I going to do top minus the bottom or right minus the left? Right minus the left. The right one is my line. So I have right minus the left. What's technically the function on the left? 0. And again, you could have left that off. So that is the base. I'm going to use that base to determine the area. It told me these are semicircles. What do we say the area of a semicircle is? Pi over 8b squared. So I'm going to kind of just fill in around it. There is my b squared. There's my pi over 8. That expression would be the area of one slice. And then how do I go from the area of one slice to the overall volume? Integrate it. So I'm going to slap down my integral sign, make sure I say it's in terms of dy, and then what numbers go in my integral sign? 0 to 6. What again does that represent? That represents this 3-dimensional solid being described, where we have all of these kind of semicircles stacked next to each other, and then we're figuring out what the volume of that shape is going to be. Questions on that? Not too bad. And again, I think it's easier than area in some ways because you don't have to think, is it dy or dx? It basically tells you when you just see which way it's being sliced. Try this problem for me then on your own. Do it without a calculator. I give you 2 quadratics. One will be upward spacing, one will be downward spacing. Maybe has a little bit more work to do because you want to define the intersection points. But you should still be able to do it kind of fairly quickly. Figure out whether you're doing it in terms of dy or dx. Find the expression for the base. Plug that into an expression for the area. And then we know that the volume is the integral of the area of a single slice. How we often see these questions on the AP exam or even like my quiz or my test, maybe like the top of the page will have one graph and part A will be like find the area, then part B will maybe be like, hey, now look at this region, but we have volume by cross section problem. So you often will have to be able to use some of the work you've already done to find area to do these problems. y equals 9 minus x squared is the parabola that is opening downward and crossing at y equals 1. Y equals x squared plus 1 is a parabola that's been shifted up by 1 and opening upwards. Do need to find those intersection points on those parabolas, kind of figure out where the region starts at and ends at. And we can do that by setting them equal to each other. So I have 2x squared is equal to 8. X squared is equal to 4. So x is equal to plus or minus 2, which makes sense in the diagram that I drew. And now I'm just going to do it step at a time. T is the base of a solid for which cross sections perpendicular to the x-axis are squared. So would this be a dx problem or a dy problem?
Yes.
Dx. So again, kind of a sample slice, you're going up and down. So when I think about the base, top minus bottom or right minus left, top minus the bottom, the top one would be 9 minus x squared minus the bottom one, x squared plus 1. That's my base. Then it tells me that those cross sections look like squares. Well, what is the area of a square in terms of b? B squared, so no pi over 8 in front, just b squared. So there's my base. Let's square it. And then in this topic, how do I go from the area of one slice to the volume of the entire figure? You integrate it. So this is going to become volume is the integral. Make sure we put dx at the end of it. And then what's going to be the starting and ending point for that integral? Negative 2 to 2. Could you simplify your answer? Sure, you could distribute the negative and combine like terms, but why would you? It just tells you to set it up, and that would be the setup. I do want to say this, not for you to rely on it, but say you accidentally flipped, instead of doing top minus the bottom, you did bottom minus the top. If it was a free response question for this one, you actually still would get full credit, because when you square something in math, what is it always going to be? Positive. So like you will get kind of lucky and just it still be positive in the same answer, so it wouldn't be marked wrong. But just good practice to still always remember top minus the bottom or right minus the left. Last question. It's kind of a weird one, I think. I'm going to borrow the same graph though. And it's the one that I think is probably the easiest one to do, but it's also the one that I see students miss the most often. I know why they miss it, but we're going to try to kind of fix that issue today. So I have that same region T. The slices are still being cut perpendicular to the x-axis. But what's weird about this one as you're kind of reading through that question?
It gives you an area.
It gives you the area. So instead of saying like, hey, the area is a semicircle or the area is an isosceles triangle, they just flat out tell you, hey, look, there's the area. Don't make it harder than it needs to be. That is the area of one slice. So how do we move from the area of one slice to volume? You just integrate it. So there's no finding the expression b. That's often what students try to do. They want to be like, oh, I still need to do top minus the bottom. But the way I think about it, they in many ways have already plugged in the b for you. Like this is the area in terms of x. We know that volume is the integral of the area of one slice, whether you're doing it in terms of dx or dy. So for this problem, what is the area of one slice? The area of one slice is 4x squared. What numbers would need to go in your integral sign? Negative 2 to 2. So we're still doing this from negative 2 to 2 because we are in terms of x. But we could skip over that step of finding an expression for b. They basically let you start off with step 2, finding an expression for the area. Yes, Simon?
So they're never gonna ask us, they're never gonna give us an area like that, 4 squared, and then ask us to find an expression for b.
No, they wouldn't. And what does this region look like? It just is going to look crazy. So basically, like, the slices are changing as x changes. So we're not even going to try to pretend to visualize what this looks like in this class. Like there's definitely programs online where you can type it in and see what it looks like. But for us, we just need to know the concept that volume is literally the integral of the area of a slice. So that's it for the notes. I did want to adjust the homework a little bit because I don't want you doing more than you need to do. So looking at this, so homework 1, continue working on that if you haven't finished it. What's new is going to be homework 2. When you look at homework 2, it's 2 questions. The first one has a part A and a part B. The second one has a part A, a part B, a part C, and a part D. The instructions tell you to actually find the volume, so it wants you to find the integral, plugging in the top minus the bottom, which for me, that starts veering real closely in like busy work land of just like foiling, power rule, plug the top minus the bottom. Like that gets old super fast. So all I want you to do for those 6 problems is just set it up. So like integral, 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 and you're done. If you do want to evaluate it, the answer key does have them evaluated, and sure, it would be great practice, but it does turn into busy work real fast if you are having to evaluate all those integrals. Do still evaluate the integral for homework 1, so I think that is important practice, but again, for homework 2, just set up those problems, don't worry about integrating them. All of your answers will look very similar because basically what's changing in each problem is just like what the area of the slice looks like. Last thing also, if you haven't filled out that form yet, make sure you do that before Friday, letting me know when you are taking the AP exam, either in May or the June administration.